All right, class, welcome back. This is 3.1, graphing equations, and we are going to talk about several different things. Particularly, we're going to talk about the XY coordinate system and how to point plot and graph equations. We're going to be talking about equations that are in the form of ax plus by is equal to c. This is the general form of a line, a linear equation. General form. Okay, linear equation. All right, so we're going to be talking about, like I said, the XY coordinate system. So this axis here is the x-axis. This axis is the y-axis. And this represents the movement in the x direction, positive when you're moving to the right, negative when you're moving to the left. This represents the difference or the distance in the y, positive when you're moving up and negative when you're moving downward. All points in this system have 2 points. They are called an ordered pair, and always the first value represents the movement in x and the second value represents the movement in y. So this ordered pair tells us where we're going here. Okay, so this point here in the center is 0, 0. That is the origin. Okay, and all points that you're given x, y are in reference to the origin. Okay, so this quadrant right here is quadrant 1. Okay, and if we had an angle, it would be opening like this. Okay, so it would open counterclockwise. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And this is a real quick review. What I want to do is plot a bunch of points. So let's plot the points 1, 3, negative 2, negative 5, negative 3, 4, 2, negative 1, 0, 2, and negative 4, 0. So we're going to plot all these points on this XY coordinate system. Okay, so this 1, 3 says that we're going to move 1 or to the right in the x direction and up 3. So this point here is the point 1, 3. This point is in quadrant 1. Okay, the point negative 2, negative 5 says we're going to go 2 in the negative direction for x and 5 in the negative direction for y. So that's going to be down here at negative 2, negative 5. Again, this should all be a complete review of the XY coordinate system. Negative 3, 4, negative 3, we're going to go negative in the x direction and up 4, that would be this point right here. This is negative 3, 4. This is in quadrant 2. This is in quadrant 3, forgot to mention that. And 2, 1. 2 means that we're going to go 2 in the positive in the x direction and negative 1. So this is the point 2, negative 1. Okay, and this is in quadrant 4. Okay, so you should be very familiar, get yourself familiar with how to plot points. And then also we're going to talk about here that this point 0, 2 means that I don't move at all in the x direction, but I move up 2. So this is the point 0, 2. Notice this is not in a quadrant, this is on the y-axis. Okay, so when x is 0, you are on your y-axis. When x is 0, you're on the y-axis. Okay, and then this point here says that I'm going to go to negative 4, 1, 2, 3, 4, and I'm not going to move at all in the y direction. So this point here is on my x-axis. And again, I want you to note that you're on your x-axis when y is 0. Okay, so that's kind of the intro to the XY coordinate system. The next thing you're going to have to answer is determine whether an ordered pair is a solution to an equation. Okay, so I'll leave that there for just a minute. Remember that when we were talking about these types of equations, and we would say x is equal to 3, and we'd say, well, is this the right solution? And if you substitute 3, then 9 equals 9, and this is a true statement. So this is a conditional equation, a linear equation, one variable, and we've got just a single point. But when we start having two variables, we have an x plus y equals 2, there's an infinite number of possibilities that x and y could be. If x was 2, then y would have to be 0. If x was negative 5, then y would have to be 7. If x was 1, then y would have to be 1. And you can see that we could do this all day. I could change x and figure out the y, the corresponding y. Okay, so there will be an infinite number of ordered pairs that can make this statement true, and each of these points are ordered pairs on a graph. So if I were to graph all of these different solutions here, so I've got the point 2, 0, I've got the point negative 5, 7, that one is all the way up here, and I've got the point 1, 1. And if I kept going and just listed all these different things, you can see that if I connect these dots, this makes a line. This is why this is called a linear equation. Okay, it's a linear equation because it makes a line. Okay, and notice though that just because there are an infinite number of solutions or points that lie on this line, right, does not mean that every point is a solution. For instance, this point 0, 0 is still on the XY coordinate system, but it does not lie on this line and would not be a solution. If I plugged in 0 plus 0 and said that was equal to 2, this is a false statement. Okay, so although there are infinite solutions, not everything is a solution. So when you're asked to determine if an ordered pair is a solution to an equation, then what this is asking is if I plug those values in or substitute those values for the variables, is the statement true? So this first one here, if we plug in the point 3, 2, is this original statement true? Well, if I substitute 3 for x and I substitute 2 for y, is the statement true? 9 minus 2 is 7, and 7 does not equal 6. So this is no. What does this mean? Not only does it not make the statement true, but it means that this point does not lie on the line. Okay, it's not on the line. That's what this means. So no, it's not a solution, and it's not a solution because it's not a point that would be on the line that these solutions make. Okay, so when would it be on the line? Let's try plugging in the ordered pair 1, negative 3. If I plug in 1, negative 3, I get 3 plus 3 is 6. And 6 does indeed equal 6, so this is true. So yes, this is a solution, and what this means is that this point, this ordered pair 1, negative 3, is on the line. Okay, so it is a solution. So I'm going to let you pause the video here and you tell me if these are solutions to this equation. Now this isn't a linear equation, but it's an equation in two variables. So we can still plug in and see if it's true. So go ahead and pause this video for a second and see if this is true. Okay, so when we plug in 0 for x, so we're going to substitute 4 for y, and we're going to plug in 0 for x. 0 to the 4th power just means 0 times 0 times 0 times 0, which is 0. So 4 does not equal 0. So, so this first ordered pair is not a solution. So this is a no. Okay, and again, the question here is this ordered pair a solution? Answer here, no. Now I'm going to substitute this negative 1, 1. For y, I'm going to substitute 1. And for x, I'm going to substitute negative 1. Well, negative 1 to the 4th means negative 1 times negative 1 times negative 1 times negative 1, which is indeed 1. So this is a true statement. So this one is a solution. And again, what that means is that this point lies on that line. Okay, so this is, again, a lot of review here. Now we're going to talk about what the definition of a linear equation in two variables is. This is actually the definition here. It is an equation that has an x and a y, and is written in this general form. Now we can write in an equation like this in another form, and that other form is called slope-intercept form. Slope-intercept form is when you have isolated y. And when you have isolated y, the coefficient now of x is known as the slope. And the coefficient, or the constant here, is known as the y-intercept. Or in other words, it is the point 0b. If I plug in 0 for x, no matter what m is, so let's do this. We have y is equal to 3x plus 5. If I substitute 0 for x, this is 0 and y is 5, so it's the point 0b. And this is our y-intercept. Okay, we'll come back to this later. How we go back and forth from one form to the other. If we were given an equation, say 2x minus 3y is equal to 6. If I want to put it in slope-intercept form, then I would isolate the y. Okay, by subtracting the 2x to the other side and then dividing by a negative 3. When you divide by this negative 3, then you get that y is equal to 2/3 x minus 2. Okay, so now this is in slope-intercept form, where the slope is 2/3 and the y-intercept is the point 0, negative 2. Okay, so I went from standard form right here to slope-intercept form. So this is how we manipulate. We solve for y when we're putting in slope-intercept form. And if we want to put it back in general form, if I were to give you a problem that was in slope-intercept form, then we would put the x on the other side. So we would subtract the 1/4 x. So we'd get that a negative 1/4 x plus y is equal to 1. And I want this coefficient to be a whole number, so I would go ahead and multiply this entire equation by 4 and get that x plus a 4y is equal to 4. And this would be the standard form here. So this one we went from slope-intercept to standard form. Okay, so this is how you manipulate the equations back and forth. Now we're going to talk about whether an equation is linear or nonlinear. Linear literally means that the equation makes a line. And the way you can tell if it's linear is if it has an x and a y and they're to the power of 1. Okay, so if I had the equation this equation here, we'd say, well, is this linear? Well, the y is to the power of 1, and so is the x. So yes, this is linear. So what would a nonlinear equation look like? Well, the other one we had, the y is equal to x to the 4th. notice here that this power is not to the 1. And so this is going to look actually like a W. And but whenever it's not to the first power, then this is going to be non-linear. Okay, so a few examples here. If I had okay, equations like this. Well, again, if I'm looking here, yes, I have a y to the power of 1 and I have an x to the power of 1, but notice that this is to a greater power, so this will be nonlinear. Okay, it will not make a line, it'll have a curve in it. Okay, and this here is also to the power of 1 and 1, and so this is linear. Okay, so that's how you can tell the difference between linear and non-linear. How we find the intercepts of an equation. Okay, so let's go to how different graphing methods. So when we're graphing, we can graph in slope-intercept form. We can graph using point plotting. And we can graph using the intercepts. Okay. So point plotting is literally that. It's literally picking a point. So it typically will be look like this. You'll say, oh, I wonder when x is 2, what is y? Or I wonder when y is 4, what is x? Etc. So if you have an equation, let's say 3x minus y is equal to 12. And I want to graph this using point plotting. Okay, well, point plotting just means, okay, let's make an XY table here. So typically they'll have you plug in -1, 0, and 1. So let's try that. So when x is -1, I don't know what y is. What I want to know is what is y. So I'm going to get that -3 minus y is 12. When I add 3 to both sides, I get y is equal to 15, which means y is equal to -15. So y is equal to -15 when x is equal to -1. Okay, and when I plug in 0 for x, this is 0, and y then is going to be equal to a -12. So when x is 0, y is -12. All right, what about when it is 1? Well, this is going to be 3, so I'm going to subtract 3 from both sides, so I'm going to get that y is equal to 9, which means that y is equal to -9. Okay, so I now have 3 points that lie on this line, and I can graph this equation. So point plotting literally just means that you're going to choose one value, substitute it, and then solve for the other. You can do this all day. You can do it with any equation. So let's look. If I wanted to graph this, okay, using this point plotting, I'd be at -1. We'll do these by 5, so we'll do 5, 10, -15 here. And then I'd be at 0, 12, which would be like here-ish, and then I'd be at 1 and 9, which would be here-ish. So this line then would look like this. Okay, and again, using point plotting, I can use any points that I want. I can say, oh, well, when y is 5, what is x, etc. So I can use this point plotting for other types of equations as well. Okay, so what is the difference then between point plotting and intercepts? Well, with intercepts, what I'm going to do is I'm going to plug in 0 for x and see what y is. And then I'm going to plug in 0 for y and see what x is. So intercepts, finding the intercepts is really just a shortened version of point plotting. So if we go back to, let's say if I have a 2x minus a 5y is equal to 10, okay, and I want to point plot this, I could do either. I could choose 1 for x or 2 for x or whatever the case is, but I could also say, well, when x is 0, remember that when x is 0, if I have like 0, 2 here, then I don't move at all in the x direction. That means, by definition, that this point is on the y-axis. And when our point is on the y-axis, we call this the y-intercept. Okay, so if I plug in 0 for x here, this is 0, and I divide by -5, then y is a -2. Okay, so when x is 0, y is a -2. All right, and when y is 0, that is 0, and we divide by 2, then x is 5. Okay, so the points 0, -2 lie on this line, and the points 5, 0 lie on this line. Okay, so this line then looks like this. So I can graph using these intercepts. Again, this is my y-intercept, because this is where this line crosses the y-axis. And this is my x-intercept, because this is where the line crosses the x-axis. Note again that the point 0, -2, when x is 0, we're on the y-axis, and when y is 0, we're on the x-axis. Okay, so that is using our intercepts. And back to just regular point plotting and when we can use it. We can use it on any equation. So if I had the equation y is equal to x squared, or y is equal to the absolute value of x. Well, let's just go ahead and point plot this and plug in points. Let's try, let's say 1 for y, 1 for x. Well, let's just plug in points for x for this one. Let's do 2, 1, and 0. So if I plug in 2 for x, then y is equal to 4. And if I plug in 1 for x, then y is equal to 1. And if I plug in 0 for x, then y is equal to 0. Okay, and I'm going to keep going here. Let's do -1. If I plug in -1 for x, then y is 1. And if I plug in -2 for x, then y is 4. Okay, and so here's all of that work for this x squared, and now let's plot these points. We've got the point 2, 4, we've got the point 1, 1, the point 0, 0, the point -1, 1, and the point 2, 4. And you can see if we connect these dots, that was really terrible. If we connect these dots, this looks like a parabola. And it is. So this is what that would look like. Okay, and this is, again, nonlinear because it does not make a straight line. It's nonlinear. Okay, and if I were to do then this absolute value of x, and we were to plug in, let's do -2, -1, 0, 1, and 2, same points we did over here for x. The absolute value of -2 is 2. The absolute value of -1 is 1. the absolute value of 0 is 0, the absolute value of 1 is 1, and the absolute value of 2 is 2. So these are my y values, and what does this graph look like then? When we are at -2, we're at 2, -1, 1, 0, 1, 1, and 2. Now these might look similar, but this one is a hard V. Okay, so an absolute value graph looks like a V, and a parabola looks like this U shape here. Okay, so point plotting, you can use it anytime to graph any equation. You should know how to graph in slope-intercept form, using point plotting and intercepts, tell whether or not you have linear and nonlinear variables or equations. And in this case, neither one of these are linear because they don't make a straight line.